One type of vector field is called an inverse square field. And so if we have some vector value function, r of t is x of ti plus y of tj plus z of tk, and that's a position vector, then the vector field f is called an inverse square field if f of x, y, z, that's our vector field, is some constant divided by the square of the length of this vector times a unit vector, where c is some number, a constant, u is a unit vector in the direction of r. So gravitation fields as well as static electricity fields are both examples of inverse square fields. So here's another example of a velocity vector, actually a vector field, sorry. Here's a vector field. F of x, y is negative y times I plus x times j. I'm just going to plot some vectors in that field at some of the points in the plane. The sketch shows better information if we plot vectors of uniform length where appropriate. I did my best to plot all these that are on circles so you could kind of get an idea what these vectors are like. So this one, this one, this one, this one, this one, that are all in this circle. And just to give you an idea, I didn't really label any points on this axis, but at this point here, let's say x was 1, 2, 3, 4, 5, and y is 0. So this vector is x is 5, y is 0, so 0i plus 5j. At this point right here, let's say that's the point x is 4, y is 4, I don't know if it is, but I'm just guessing that. Then this would be negative 4i plus 4j. That's what this vector is, negative 4i plus 4j. And at this point, let's say it's the point 0, 5, then we'd have negative 5i plus 0j. So that's this vector pointing this way. And you could do that with all these vectors. I just did it with these couples so you'd understand where I got this drawing, and it was convenient for me to sketch the vectors on these concentric circles, but you understand every point in this plane has this vector, and this is our vector field. I hope that makes some sense to you.